Presentation today is Wiff, the Wayfair Sniffer. If you don't know who I am, my name's Dan Rowe. I work at Wayfair.com. You can catch me on Twitter, on GitHub. I lead the infrastructure tools team at Wayfair. That's made up of two primary teams. One is the internal tools team, where our customers are the employees of all of Wayfair. And then the dev tools team, which is our customers are the engineers. And I'm also, if you don't know, a big reptile enthusiast. So I breed pythons and large lizards at home. And so JetBlue wouldn't let me get a large lizard on the plane today, or for this trip. So next time I'll give a talk on monitoring and alerting of reptile environments. But today we're gonna have to just do the network sniffer. But if we bring it back to Boston, there will be a reptile show. And everybody likes cats, but even cats like lizards, so just keep that in mind. So just a shout out to Sean Nichols and Nishan. They aren't here today, but they are the primary developers of this, so if you get too far into the underbelly of the Java, I might have to defer to those guys. So who is Wayfair? Wayfair is starting to be more well-known. We were CSN stores. A couple of years back, we migrated to Wayfair.com because we thought we were able to brand that better. And so far, it's worked out really well for us. We do have a couple other brands that we market, and we've got some pretty nice stats for what we're doing lately. Okay, so a lot of times you come up here. I think cron tabber was a good example. You're presenting a piece of software and you're like, why are you doing it that way? It doesn't make any sense to me. Why don't you use this tool? Or why didn't you do it this other way? And I think environment, what you're comfortable with, things like that play a big part into the design decisions. And so I just wanted to give a quick overview of the Wayfair environment so that you kind of, hopefully we can stub some of those questions before they start. But feel free to ask them later. So we have active data centers. Primarily, the bulk of our environment is a load balancer fronted PHP web farm. Other than that PHP web farm, it's essentially a jungle. It's a heterogeneous environment. Pretty much what you want to run to get the job done, and it spans both Linux and Windows. All right, so a little bit of our logging infrastructure. We are big fans of Logstash and Elasticsearch and visualizing that through Kibana. We like to put syslog messages in there, lots and lots of application logs in there. This talk is about getting the network traffic in there, and all the other random things like commits and essentially anything else we can think of. And we like Elasticsearch because, like the little squiggly lines at the top, we can kind of correlate the data between the different sets of data to build a bigger picture. And once we get that data in there, we can use kind of different monitoring and alerting tools to kind of pull out some higher level meaning from that. We use Kibana a lot. We have a lot of graphite metrics as well. Kibana and Grafana need to kind of get together and make one thing. Until then, we built HUD dashboards, which does that for us. It's not quite as pretty, but it's very functional. We also have an ad hoc query web UI. So a while back, I wrote Tattle for kind of ad hoc graphite metric alerting, which was awesome. One of the people on the team just recently wrote a similar tool for querying off of Elasticsearch. So anybody in the company can go to Kibana, build a query, like that query, stick it in this web UI, and now get alerted on it. And it kind of eases the pain for ops or kind of having to roll your own Nagios config. And we also have Zabbix in the environment. All right, so we got a little bit of background about me, a little bit of background about Wayfair, what the environment we're getting into looks like. Let's talk a little bit about Wiff. So what is Wiff? It's an out-of-band traffic sniffer and analyzer that is kind of vague, I guess, and the picture of the meat going into the grinder doesn't kind of help describe that. But it's kind of like Wireshark as a service. It's currently in beta at Wayfair, and essentially to kind of twist the out-of-band network traffic sniffer into a more elegant sentence, I guess, it's essentially a packet processing pipeline. And we all like to pipe things from one command to another, and so Wiff is a good kind of way for us to pipe those packets from one thing to another. So if we kind of zoom way out, the higher level overview is you feed packets in, do something with packets, and data comes out. Pretty typical pipeline. Once it's out, you can report, analyze, and profit. All right, let's zoom a little bit further in and talk a little bit about how you get packets into there. We started with kind of Wireshark off the NIC kind of input of the traffic. That worked for some scale. Once we got to a certain point, we wanted to kind of divide and conquer, and TCP dump does a really good job of taking these files, dumping them into PCAP files, and you can configure it to be a ring buffer. So you can set Wiff up to listen on to the NIC. If you have low traffic, you can give it a single PCAP file if you want. You can give it a folder to watch for files in, or if you are feeding itself to itself kind of in a pipe style, you can feed it to RabbitMQ and it'll pull off RabbitMQ. And because it's just looking at PCAP files, it doesn't care if it's inbound, outbound traffic, internal traffic, external traffic, things like that. As long as you're giving it packets, it'll take them all. All right. Once you have these packets, you can configure which protocols you care about, kind of like a TCP filter. Pick whether port 80, 443, or just kind of some basic TCP. And it sifts through those packets and starts to process them. Currently, we support HTTP, HTTPS, basic TCP, but you can add your own pull request welcome. Little star next to HTTPS. It requires the keys to the kingdom, so essentially it needs to have the keys to decrypt it. Because most people have patched the Heartbleed problem now, you can't go get them yourself. We now actually have to keep a copy ourselves. And so once those are on there, if they're on the system, you give it an IP to key file mapping, and then it starts to decrypt those. We've implemented the ones that Wireshark Snake Oil Cert uses, and we've used the most common ones that our config supports, but it's pretty trivial to add support for other ciphers. So again, pull request welcome. We currently don't store the response body or the request body, just because of PCI and other reasons, but it's a config flag, so you can. I do warn you that the space that it requires is significantly different if you start storing the bodies of requests and responses. And because it's a lot more CPU intensive to decrypt all of this data, all this traffic, it is in alpha while we kind of tune the performance at high volume. All right, so what is HTTP processing? Essentially, you feed the packets in. Wiff keeps track of all the connections. It orders the packets kind of by sequence number, stitches the payload together. If it needs to decrypt it, it does so. And then in our case, our reporter is configured primarily for Elasticsearch. So it wraps it up in a nice JSON document and ships it off to Elasticsearch for us. And I kind of alluded to it. Reporter is a class in Java that will send that data somewhere. So once it's stitched together into an object, you can JSON encode it, send it to Elasticsearch. We actually send it to RabbitMQ, so we can just pump RabbitMQ full of these things, and then Elasticsearch feeds off of that. We have an example reporter in there that if you're kind of developing on your desktop or want to run it at low volume, it'll write straight to Elasticsearch. It does run on Windows, if that's a desire for you. Okay, so reporting, analyzing, and alerting. And for us, I know some of the talks yesterday alluded to this. Wiff is really only the beginning of the pipeline. We're not really doing a whole lot of analyzing. That's what Elasticsearch for us is. It's more about getting that bulk of information into Elasticsearch so that we can then start the journey of analyzing. And so we have some Kibana friendly kind of data format, so the timestamps are there. We do some analyzed and unanalyzed fields when we build Elasticsearch indexes so that your pie charts and your graphs look nice and they don't chop them up in weird ways. And if they're not in the repo right now, then they'll be coming soon, so we can have some example JSON. But if you go to the Kibana training tomorrow, you'll probably be able to build your own pretty quickly. And then coming down the pike is alerting. Alerting off of Elasticsearch queries is something that we need in our building. So kind of like a tattle for Elasticsearch, but we'll let one of my other engineers give that talk. And then whatever else you use alerting for Elasticsearch right now. And so there's a lot of pessimism, both in the company and outside. It's like, yeah, whatever. I can log that, My web server has logs. My application server has logs. And that's great. We think you should have logs. Log everywhere. But Wiff is more of a companion tool, and it's not a replacement for logging at the lower levels. I think it's just an additional vantage point to be able to gather that information from. So, great. It logs stuff. It's a companion tool. Where does that actually fit? And I kind of normally turn that around and ask, like, where do you need it to go? What could it do for you? It's kind of a choose your own adventure. It can track inbound traffic. It can track outbound traffic. And so it really depends on what your environment looks like and what traffic you want to kind of record. So an example for us is if you put it in front of the load balancer is kind of loaded because it's off an aggregator network tap, so it's not actually in front of the load balancer, which is a plus for us. So it just happens to get a copy of all that traffic. And so the benefit there is it sees what others can't. So if the load balancer is misconfigured, say you point it at an Nginx port or something that doesn't exist, or a backend for Nginx that just isn't responding. If the load balancer isn't receiving that traffic, then it can't log about it. If your web server doesn't get it down to the stack, if that's where you're doing most of your logging, if the load balancer doesn't hand it that traffic, you can't log it. If the request doesn't complete, so you're trying to troubleshoot a sticky situation where you're seg faulting or something else, you might not get that log data. You might want to turn on the recording of bodies in your data in Wiff so that you can get what those particular request parameters were that was causing it to seg fault. Same thing with PHP. If it segs faults, you might not get the application level logging that you're wanting, or whatever application logging that you want. Also, a lot of instances, we had, as soon as we fired up Wiff the first time, we noticed that we had a bug in our set cookie algorithm. So we were setting a cookie multiple times on the outbound request, but Nginx only logs the first instance of that cookie. So Nginx says in the logs, hey, you set cookie, that's awesome. But if you looked at the actual output in the TCP dump in Wiff in a JSON document, there was clearly 4 to 5 copies of it in an outbound request. And obviously that's not a good thing. That's wasted bandwidth. That's not to spec. And so it picks up on things like that the logging was inadequate for. Granted, you could go back and forth and say, hey, why don't you just fix the logging? We did in Nginx, but it's things like that you can gather that information without having to touch your application, which is kind of helpful for a lot of different environments. And so that kind of leads me into the other benefit. It's real-time traffic monitoring. So you put it in front of your load balancer, it's getting a copy of all that traffic. It gives you great visibility into all of your traffic without slowing anything down. If Wiff goes down, if Elasticsearch goes down, if syslog backs up and blows up your box, you don't have to worry about those issues because it's all out of band. So it's kind of easy on the maintenance side of things. And you don't have to change your application or anything. So out-of-bound Mousel. So at Wayfair, we have a thing at the load balancer level called the Mousel, which is the mother of all web server logs. because we have this heterogeneous environment, everybody logs in different ways. And Logstash is great because it, takes the different logging types and aggregates them together. But if you log at the load balancer, you don't have to worry about that. You're getting all requests. You pipe it to the different backend servers, but it all comes out in the same format. And so kind of Wiff for us is a out-of-band Mousel, and maybe most people don't have a Mousel, so this would be helpful for them. All right, so we talked a lot about kind of inbound traffic primarily. You're in front of a load balancer, you're getting all this web traffic, that's awesome. That's kind of can be related to probably by a lot of people here. Another thing is outbound traffic. We have a lot of interesting setups at Wayfair. We run warehouses, we run appliances, third-party appliances, some proprietary or off-the-shelf software that runs on Windows boxes, things like that, that we don't have a lot of visibility into or ways to instrument, like we could just throw 100 statsd calls in our PHP. These are kind of black box setups for us. And so some of the way that we get insight into that is by running Wiff on that Windows box. And it can calculate when this application is calling out to third-party APIs, what the round-trip time of those packets are. If it's not HTTPS, then it can kind of decode what those requests are, what are the response for header pairs, things like that, and give us a lot of insight into things that we weren't otherwise able to see. And it helps for things like our shipping algorithm, where we need to call out to a third-party appliance to get some additional information. And a lot of times that appliance will then call out to the internet to get information it needs to make that calculation. And knowing how much time for our service call goes from kind of our code to that box and from that box to the third party outside, is knowing both sides of that is important to us, so that we can know whose fault when that thing slows down. It's also kind of helpful when you're troubleshooting issues on your desktop. We've been developing it long enough now that you can run it on your desktop, and a lot of desktops at Wayfair are Windows, so you fire it up, it's logging your traffic to Elasticsearch, and you can kind of investigate what's happening there with Ajax on customer service agents, things like that. All right, I don't have a fired up demo, so I took some screenshots. Essentially, this is probably very blurry and hard to read, but this is an example of a request response pair. It gives you the headers, essentially everything that you would expect from a request and response pair in JSON, with both what cookies are sent in, what set cookies are sent out, and then also some top-level data like source IP, port, destination port, where this data came from, like which Wiff source, things like that. And then I would dive a lot more into the Kibana stuff, but we're going to have a nice demo of that tomorrow, so I'll just give you a quick peek. But essentially, this is the map, the hosts, response codes, kind of the volume of traffic we're getting, top request pages, user agents, broken down by IPs and by server. And so this is all out-of-band data that we're getting. So there's no logging, there's no instrumentation. Essentially, it's a network cable that gets piped to Wiff, and it builds essentially the same data that you can get out of Kibana through a heavily instrumented Logstash environment. And then, with all the same bells and whistles of being able to filter down by server group, server ID, or anything else in that Elasticsearch JSON document. So here it's just filtered down by our redirector servers, so you can see that the response code for 301 is the big bulk of this request, and the top page request is a redirecting URL. And then this is just another way to slice it with filters. And I think I might have been too quick. Things to do is improve the SSL decryption performance. We have a way with RabbitMQ to kind of distribute the processing of that, so we're going to be ramping up that. Adding additional protocol parsers. So we do HTTP and HTTPS well. We have some TCP basic stats. We want to get more of that. And then we do a lot of mail, FTP, and DNS. So we're looking to add those protocols in the future. And then additional reporters. We have a in beta, not committed yet probably, a StatsD reporter, so you can kind of build StatsD metrics off of this data, send it straight there, and it's easy to implement additional ones. Some notes, like everything else, you need to monitor it. You need to monitor for dropped packets to make sure that because it's in a unique situation where it's not on the box, you can't ask the TCP connection to retry if you missed a packet, things like that. So if you get a lot of dropped packets, they're going to be unstitchable and you won't get that information. We don't support SPDY or WebSockets. It's purely HTTP at this point. And to be perfectly honest, it runs well for us, so it's kind of a works for us. We'd love to hear your feedback as far as if there's things that would make it run better in your environment. And then images that were used in this presentation. And then that'd be it. And it is on GitHub now, so GitHub/Wayfair/Wiff. We did tag a release for it, so you can download a jar instead of having to build your own if you want to kind of test it. I mean, granted, that's kind of like curl to SH, but you can trust us. So that's what I got. Questions?
Are you encoding the real host data into the response that's seen, or do you plan on running Wiff in front of and behind the load balancer so that you can get an insight into which real server is misbehaving behind the load balancer?
Sure. Let me answer that with that. Sure. The question was, do you instrument Wiff before and after the load balance so you can see, great, the traffic is happening well or working well as expected before load balancer, but what about behind it? The way we do it is we instrument a response header. And so in this bottom right-hand corner, you can see a header that identifies each server for us. And so we can, if it's a response that we see, we know what server it came from and are able to kind of narrow it down from that. And with the the Kibana stuff, you can kind of filter that box in or out.
Is there anything on your roadmap for SIP traffic?
For SIP traffic? No, but there's nothing that says it can't be. We have a fairly large call center, so I'm sure the comms guys would like that. Throughput is pretty close. So we have it on a 10 gig NIC, but we're not anywhere near 10 gigs. Probably around a gig or so would be my guess. But that's only kind of benchmark testing. It's really up to how you tune the buffers and things for TCP dump and what your NIC can handle. We had to set up a byte buffer array to kind of conserve on memory. But as long as you're using TCP dump's ring buffer, it's as fast as you can kind of pull it into those files. Cool. Thank you.